Lesson 7, identifying proportional and non-proportional relationships in graphs. So our opening exercise, we have candy bars sold and money received from those candy bars sold. It says Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold compared to the money he received. Is the amount of candy bars sold proportional to the money Isaiah received? And how do you know? Well, if we compare that, the amount of money over the candy bars, remember y over x, we have 3 over 2, which equals 1.5. We have 5 over 4, which equals 1.25. The answer is no. All the ratios do not simplify. To the same number. Now, let me spell that out. Now, let's do a little review about the coordinate plane. Let's label the origin, which is right here. This is 0, 0. Label our x and y axes. Here is our x. Here is our y. Next, we're going to label the quadrants. We have quadrant 1, quadrant 2. I'm labeling them in Roman numerals. Quadrant 3 and quadrant 4. If you label them with regular numbers, that's fine. I've learned them in Roman numerals, so that's what I do. And then number the axes. To the right is positive, so 1, 2, 3, 4, 5. To the left is negative, negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. And you always count them on the lines, not in the spaces of the box. Next, we have an ordered pair. Our ordered pair is always labeled X first and then Y, just like the alphabet. So next, we have our exploratory challenge, and we are going to, from the table, it says using the ratio provided, create a table that shows money received is proportional to the number of candy bars sold, and plot the points in the table to our right here. So to show that it's proportional, what I can do is I can multiply each of these by 2. So 2 times 2 is 4, and 2 times 3 is 6. So if I multiply the 2 times 3 would be 6, times 3 would be 9, times 4 would be 8, and times 4 would be 12. So now to plot these numbers, I have 2 and 3, so 2 and 3 would be right here. Four and 6 would be here. 6 and 9 would be right here. And 8 and 12 would be right here. It says, what observations can you make about the arrangements of the points? They form a straight line. It says, do we extend the line in both directions? Explain why or why not. No. You cannot sell a negative amount of candy. So next, our important notes. Here are the characteristics of graphs of proportional relationships. There's two things you have to have. The first thing is they have to form a straight line. So it has to form and second, the straight line goes through the origin. So next, let's use this to find out what ones are proportional and which ones are not. So example 1 says, graph the points from the opening exercise. Okay, we have 2 and 3. 4 and 5. 8 and 9. And 12 and 12. It says, is the relationship proportional? No. It is not a straight line. And does not go through the origin. Next it says, graph the points provided on the table below and describe the similarities and differences. Okay, well, we have 0 and 6, which is right here. We have 3 and 9, so 3 and 9, which would be right here. Then we have 6 and 12, so 6 and 12 would be about here. 9 and 15, so 9 and 15 would be about here. And then we have 12 and 18, which would be 12 and 18, which would be about there. So our similarities does not go through the origin. The differences is example 2. Is a straight line. And is the relationship proportional? No. It has to be both. Okay. And that ends our lesson.